Let us solve question number 3, part B. The question involves solving a system of simultaneous equations using Cramer's rule. If you have a system of simultaneous equations like this can be solved using Cramer's rule. And how can we do it? To solve this simultaneous equation, we get the value of x by dividing dx over d. The value for y is equal to dy over d, and z is equal to dz over d. Dx is the determinant of a matrix formed, and dy is another kind of matrix, dz is another kind of matrix. So dx is equal to the determinant of this matrix, e1, e2, e3, b1, b2, b3, c1, c2, c3. That 3 by 3 matrix is its determinant is what we are calling dx. Dy is equal to this matrix, a1, the determinant of this matrix, a1, a2, a3, then e1, e2, e3, then c1, c2, c3. The determinant of that matrix is the one we are calling dy. dz is equal to the determinant of this matrix, a1, a2, a3, b1, b2, b3, then e1, e2, e3, that determinant. And d is the determinant of this matrix formed by that those 3 simultaneous equations, that is a1, a2, a3, b1, b2, b3, c1, c2, c3. The determinant of that matrix, we are writing it as d. The simultaneous equations given. Now let us use Cramer's rule to solve these simultaneous equations. And f1, we are going to get it by df1 over d. And f2, we are going to get it as df2 divided by d. And f3 is equal to df3 divided by d. That is what this is the Cramer's rule, and we are going to use it right now. And we go. df1 is the determinant of df1 is the determinant of this matrix. -2, 1, 1. Then here 1, 2, -5, then 2, 1, -3. We are required to get the determinant of that matrix, and when we get it, it is the one that we are referring to as df1. How do we get the determinant of this matrix? To get the determinant of a matrix, we are supposed to get the product of the elements in a row with their cofactors. So we take row number 1, we get the elements, we multiply by their cofactors, then we get the sum. So we start with the element 1, and the cofactor of element 1 is row number 1, and this column here, you remove those elements. The elements that you are left with, that is 1, 1, 1, negative 3, you get the determinant of those elements. You multiply by 1. So the element is 1 and the cofactor is the other one, minus, we get the second element is negative 2. Negative 2, we multiply by, we remove the elements that are in the same row and the same column with negative 2, and the elements are 2, 1, 1, negative 5, negative 3. Those are the elements. Then we remove all the elements touching the same column and the same element with 2, and that is 2, 1, negative 5, 1. We get the determinant, then we multiply. We need to get negative 4 for the first one there, minus 2, plus 14, and this gives us 8. df1 is equal to 8. Then we go to df2. 1, negative 1, negative 2, negative 1, then 1, 2, negative 5, 2, 1, negative 3. We get the determinant of that matrix. Its determinant now will be equal to, again, its elements. We use them to get the determinant. We can use any column or any row, but let me use row number 1 to get our determinant. So, and remember, the determinant of a 3 by 3 matrix is the sum of the products of the elements and their cofactors in a row or in a column. So the element 1, you multiply by, we are going to remove that row and that column. The other elements which are remaining, those elements, they are forming a 2 by 2 matrix, and we are going to get its determinant. That determinant forms, if we place the sign, it forms the cofactor. So here we have 2, 1, negative 5, negative 3 there, minus. The reason as to why the second one we are putting minus, because the second sign should be a minus. Then 1 multiply by, and when we get the determinant here, this one, df2, now becomes, it becomes negative 1. This is minus 7, plus the last one here is 24, and the sum becomes 16. Therefore, df2 is equal to 16. df3 is equal to the determinant of this matrix. The matrix is 1, negative 2, negative 1, negative 2, 1, 1, 1, 2, negative 5. We get that determinant, and that determinant becomes minus negative 2. You multiply by the determinant of this matrix. The next one is 1 multiplied by the determinant of, multiplied by that determinant, and df3 becomes negative 7. That becomes negative 7 plus the whole of this one here becomes 24, and the whole of this one becomes minus 1. df3 is equal to 16. Let us now get D is equal to the determinant of this matrix. Let us get the determinant of that matrix, which becomes, I'm going to use the first row here to get my determinant. So I will use 1, -2, and 2 to get the determinant. And the product of these elements with the Jacob factors, the sum of the products will give me the determinant. So the product here is 1 multiplied by minus, the next element is -2 multiplied by the determinant of this matrix. The next one is 2 multiplied by this determinant here. We get, if we work this one out, this one out, therefore we get, rather we also work out this one, we also work out that one. The result here is 8. So D is equal to 8. Let us now compute for F1. F1 is equal to dF1 divided by D, which is equal to dF1 is equal to 8. Therefore, this is 8 over D is equal to 8. So 8 over 8, and this one becomes 1. Let us now work for F2. F2 is equal to dF2 divided by D. But from what we have worked up there, dF2 is equal to 16 divided by D, which is 8. So we get 2. And we work out F3. F3 is equal to dF3 divided by D. dF3 is equal to 16 divided by D is 8. So 16 divided by 8, you get 2. And therefore, the solution for this simultaneous equation is F1 is equal to 1, F2 is equal to 2, and F3 is equal to 2. And those are the 3 solutions for these equations.